Hello, my name is Heangwoo Lee. The topic of my thesis is develop of PV module applying building envelope technology for energy reduction. Next page. According to data by the Korean Energy Agency in 2017, energy consumption in the building sector accounted for 26% of total use of energy, and this figure is expected to increase gradually. Therefore, various study and technological developments are being pursued to reduce energy consumption in building sector. The building envelope is an important factor in determining by energy efficiency rate of building in terms of protecting the indoor space from the external environment, and is also the most valuable area to heat loss in indoor spaces. Therefore, improving the performance of building envelope is an important aspect to save building energy. Among the relevant technology of building envelope, the light shelf saves light energy by introducing outdoor natural lights deep in the room. And my study has been conducted in recognition of its efficiency. A recent study focused on saving building energy by attached PV module, another building envelope technology, to the light shell. Next page. However, most previous study on light shell combine PVs on the top of the reflex, which acts as a disadvantage because the efficiency may be degraded by soiling due to accumulating dust on PV space. Flat light shell are also unsuitable for maximizing their lighting efficiency because they reflect natural light in the form of minor reflection. Therefore, the purpose of this study is to build basic data in rate field by proposing a building envelope technology that can simultaneously increase the lighting performance of light shell and concentration performance of the PV module and examine its performance. It's about this page is surgical review. Building environment primarily divide the indoor and outdoor area and create a comfortable indoor environment from outdoor environment facts. Building environment elements technology include system related to insulation, daylighting, and shading. The light shelf as shown in picture is a building envelope element technology that can efficiently save light energy by introducing external natural light deep in the room through reflection. The variable that determine the performance of light shelf include the width of the reflected angle and height and refractory recently a wide variety of studies have been conducted on light shelf by diversifying the shape of reflection or by integrating IT technology. Next page. This page is technology development. This study focuses on the light shelf and PV in terms of building envelope technology and compare the following steps to efficient perform the main function of the concentrating light and daylighting by apply the right shelf and PV. First, a curve reflect was applied to the right shelf with the PV module. The reason why this study choose a right shelf with a curve reflect is that unlikely a flat right shelf includes diffuse reflect in the processor of reflect external light, natural light to improve their light performance. Next page. Second, this study attached a PV module to the curved light shelf and suggests that the PV should be attached to the bottom of the refractor instead of the top. This is because the PV are variable to solving, but this problem can be solved by installing the PV to the bottom of the right shelf. PV. In addition, when the PV is attached to the bottom of the curved light shelf, it can simultaneously concentrate light and perform daylighting depending on the angle of the light shelf and the power contribute to saving building energy. Next page. This page is the configuration for performance evolution. The articular solar illumination apparatus was capable of simulating the brightness and altitude of the sun, but could not simulate azimuth. As shown in picture, a total of 4 illumination sensor was installed to analyze the indoor illuminance of the test bed. When each illuminance sensor was conducted to the right to providing light control. This study evaluated the performance of the performance building envelope according to the following method. Next page. Next page. Okay. First, to validate the energy saving performance of the PV applied light shelf, which is the performance building envelope technology in this study. It was compared to a conventional flat light shelf. The height and width of light shelf was 108 meter and 0.6 meter. Respectively, the height of the light shelf was set by considering the view of the window, and the angle was changed from 0 degree to 30 degree in increments of the 10 degrees constant movement. Second, this study calculates the consumption of light energy to validate the effectiveness of saving light energy. In case set above, this was the performance by calculating light dimming light control level and consumption of light energy for each case that satisfied the optimal indoor light illumination. In case 3, which apply a PV module, the amount of energy generated by concentrated light was also monitored. Next page. Third, the light control to maintain the optimal indoor illumination was only performed when the illumination sensor was 400 lux or less, in which the dimming level of the lighting connected to the illuminance sensor showed the lost value was rise scarcely. The writing control, and when all of the right answers satisfy 412 laws during the process, and the consumption of light energy at this point was monitored. Fourth, this study linked performance evolution to summer, which is a limitation of this study. Next page. This study developed a building envelope technology that combines a light shell with a PV module and evaluates the performance of saving building energy. The results are as follows. First, table show the performance evolution results according to the angle of conventional flat light shell, where the increased light shell angle was advantage for saving lighting energy. This is because the amount of light enter the room increase at the light shell angle increase as shown in pictures. Okay. In particular, during summer, although the consumption of light energy may be high because of the small amount of natural light enter the room due to high altitude. This problem can be solved by installing a light shell. The optimal angle of flat light shell to reduce building energy was 30 degrees, and the mounting of light energy used to satisfy the optimal indoor illuminance was 0.1544 kilowatt hours. Second, table showed the performance evolution results of curved light shell with a PV module, which is the building envelope technology proposed in this study. The optimal angle of the curved light shell based on this, the amount of light energy used to satisfy optimal indoor illuminance was 0.129 kilowatt hour. This proved the effectiveness of curved light shell by reducing the light energy by 10.4% compared to flat light shell. As shown in table, the curved light shell with a PV module can also reduce energy through the PV module attached to the bottom. Okay, and the optimal light shell angle was 30 degrees even when considered the energy produced by the PV module. Considering both daylight and lighting concentrated, the curved light shell with a PV module can be saved building energy by 16.6% compared to conventional flat light shell. This proved the effectiveness of the curved light shell with a PV module in terms of saving building energy. This is the conclusion of this study. This is a basic study of development of building envelope technology by integrating two respectively building envelope element technology to solve related problem and maximizing energy saving. The main finding is as following. shell with a PV module. The purpose of building envelope to efficiently reduce building energy. The PV module was attached to the bottom of right shell to solve problem related to reduce PV generate efficiency. Second, the optimal angle of the flat right shell for saving right energy was 3 degrees during summer, and increase right shell angle during summer increase the amount of natural light entering the room, thus improving the efficiency of saving indoor light energy. Based on the optimal angle of the flat light shell, the amounting of light energy used to satisfy the optimal indoor illumination was 0.2155 km/h. Next page. So, the optimal angle of the curved light shell with a PV module, which is a building envelope technology, proposed in this study was 30 degrees, and based on this, the amount of light energy used to satisfy the optimal indoor illumination was 0.129 kWh. This proved the effectiveness of the curved light shell with a PV, as it can save light energy by 10.4% compared to conventional flat light shell. The curved light shell with a PV module can also reduce energy through the PV module. As a result, it can reduce building energy by 6.6% compared to conventional flat light shell,